Hi, this is Josh with Over the Shoulder Coding, where I help you prepare for software engineering interviews by guiding you through solving real problems. Today we're back with LeetCode problems, and we are working on number 3, longest substring without repeating characters. I'll work through the problem, go through the test cases, and then show you a couple optimizations that are going to make the performance a little bit faster and wow your interviewer. So let's jump into the problem. Given a string S, find the length of the longest substring without repeating characters. So they give us a few examples. Let's make sure we understand what they're asking for. With a string ABC, ABC, BB, the output should be 3. And that's because ABC here or here is the longest substring and it has a length 3. In the second example, if we have all B's, we only have a substring of length 1 without any of the characters repeating, so the output should be 1. In this example with PWW, KEW, we might have up to 4 unique letters, but we have WW recurring here, so this is not a valid substring. The longest substring would be these 3 letters or these KEW at the very end. So the answer being WKE will return 3. So let's give ourselves a easy thing to start with. If we get a string of length 0 or 1, we know pretty easily what we'll return. So if length of string equal to 0, we just don't need to return anything. If the length of the string is equal to 1, we can return 1, since there's only going to be one substring, and that's going to be the longest substring. Where it's going to get more interesting is if we have multiple letters in the string. So if we do, we'll need to do something to loop over all characters. And then within each of those characters, check the substrings for uniqueness. And then check to see if we have a new longest substring. And then at the very end, after we're done checking everything, we can just return the length of the longest substring. So we'll need something to actively keep track of what our longest substring up until this point is. And we can just easily start with the first character. So longest substring. And that handles the base case as well. If we have a substring of length 1, we'll automatically get the longest substring and return its length, which should be 1. So for all other characters, we need to loop over. So for character in S from the next character to the end of the string, we'll want to do something here. And what we'll want to do is to check all the substrings up until this point and see if it's valid. So we'll have a set that keeps track of current substrings. So current substrings will start out as a set containing the longest substring. And for each iteration through this, we will want to check the substring for uniqueness. So if the new character is in the longest, if it's not in the set of current substrings, then we will add it, check, and go ahead. So for here, we will need to loop through all current substrings. We'll add the new character to the current substring and then do the comparison. So this is pretty naive, and we also don't have anything for looping back over and continuing to the next character. We kind of just keep it in the current substrings. But we can just look through what one iteration might look like, starting with the ABC. So if we started with ABC and S equals ABC, longest substring here is going to start out as A. And then we're going to start looping through this, which is going to be BC. And current substrings is just going to be a set that is A. So for substring and current substrings, that means substring is A. If the character, which is B, is not in substring, which it is not, then the new substring is going to be A plus B. So that's going to be AB. And the length of AB is 2, which is greater than the length of A. So longest substring is now going to be AB. And if we get to the end, then we'll return the longest substring. What we need to do now is to keep track of both AB in our list of substrings and the possibility that we want to start a new substring with B. So in order to do that, we will need a new set of substrings. So next iteration substrings will be a new set. And for every substring in here, we'll want to add the substring plus the character into the next possible iterations. So if the character is not in the substrings, then we will want to add new substring to the next substrings. We'll also want to add just the new character B by itself. So next substrings. We can just start it off as a set containing character. And at the very end of the iteration, we will replace the current substrings with next substrings. But we'll want to use copy so that we actually have a new entity replacing current substrings. So let's go ahead and test this out. What it would look like if we went on another iteration is that longest substring would now be AB. The current substrings would be AB and B. So the new character would be C. Next substrings would start out as C. And first we'd start out with AB. C is not in AB, so we'd get ABC here. Next substrings, we would add ABC. And ABC would be longer than AB, so we would go and substitute longest substring, and then we'd replace current substrings, and that'd be ABC, and we'd also loop through B here, so then we would have B, and we'd also have to check BC, but BC is not going to be greater in length, so we won't replace longest substring. Looks like we have an issue here where our output's not as expected, so let's add some log statements to make sure we know what's going on. let's check which characters we're iterating over, as well as what the value of each substring is when we're iterating over it. So we start with longest substring as A. The first character we're going to start with afterwards is B. So the substring is A, AB. We'll loop back around. It's not a really helpful print statement because we don't know what the state is at each situation. So let's add some more things in here. So for the first iteration, let's just check what current substrings is at. And let's also print out what the new substring is. Let's also make an easier test case, ABC, just to see what's going on. So we'll start with longest substring is A, current substrings is just A. We're looking at the character B and adding it to or comparing it to substring A. So we should have a new substring AB. The next iteration of current substrings will be AB and B. We'll have a character C. With a substring AB, we'll have ABC. With a substring B, we'll have BC. And it looks like longest substring is not being replaced by new substring because we have this double equals. So if we run the code again, looks like we're getting it properly replaced. So let's go back to the more complex test case and see that we are doing it properly. All right, looks like our submission was accepted. We can delete these print statements and submit it. So it looks like we passed all the tests and we run pretty quickly. But there is one other thing that we can do to speed up our tests a little bit. So let's just make sure we understand this solution. We're creating a list of substrings to go and check and add the new character to all the substrings in our set of substrings. If it is unique, meaning the new character is not in the existing substring, then we are going to add it to the next iteration and also check that we have a greater length. One thing that we're doing that's pretty inefficient, you can see in here ABC, ABC, BB, there's only 3 unique characters, and ABC we find is a solution with length 3 already. If we know that there's only 3 unique characters and we already found a solution with length 3, then we can just go ahead and return and not loop through the rest of the string. So it should save us a little bit on runtime. And in order to do that, we want to check the number of distinct characters. So we'll turn the input string S into a set and get the length of the set. So number of distinct characters in the input set is going to be equal to the length of the set of all the input characters. And if at any point through checking we realize that if the length of longest substring is greater than, or, well, it would have to be equal to first, is equal to the length of the number of distinct characters, which is the maximum possible length of the longest substring with unique characters, then we can just return the length of the longest substring. Now let's just test to make sure it still works on ABC, and I think it will be a little bit faster. So here our runtime goes from over a second to 10% smaller, and we're still using the same amount of memory. So we're running faster than quite a few of the different solutions. Now there's a bunch of other things that you can probably do to speed this up, but this is a pretty simple solution that gets the answer, and it makes it so that anybody coming after you who's using your code base can read it pretty easily and understand what's going on. So if you like the solution, hit the like button. If you had any questions, please leave a comment below. I'll try to answer those in the questions, and subscribe so you can see the next video. Thank you.